example, adult internet users. This is on section 7.2 on sample proportions. We already magically know somehow that 75%, okay, so we already know P, which isn't usually the direction that we go in statistics, but remember, this is a tool that's getting us to be able to figure that out eventually. So we know 75% watch Game of Thrones, okay? We know this about our population. So now we're going to see what happens if we take a sample survey. If we more than just take one sample, we actually create a sampling distribution. So we take 1,000, we keep taking 1,000 adult internet users and asking, if they watch Game of Thrones, and then we plot those p-hats. The mean of that would be the mu sub p-hat is just going to also equal 75%, because the mean of the sampling distribution of p-hat is the same as the population proportion. That's the reason. The mean of the sampling distribution of p-hat is the same as the population proportion, and we'll use that fact to figure out how many orange Reese's Pieces there are, because we'll create our own sampling distribution of p-hat. So it's just the same. The standard deviation of p-hat is equal to the square root. This is how we use the formula that's given to us. Well, the formula is p1 minus p over n. So we just do square root of 0.75, and then this will always be like the complement, 0.25. That's not p, over the sample size of 1,000. And we want that to be big for a small standard deviation. If you plug that in on your calculator, you'll get approximately 1%. So if we kept taking samples, the average distance away from 75% would be 1%. So it's not very far away. That's a pretty small standard deviation. And then I'm going to make this, instead of the 10% condition, I'm going to call it the independent condition. But you are making sure you're not sampling more than 10% of the population. But this is a weird instance to check the independent condition, because these are just people that you're surveying. It's not like you're grabbing Reese's Pieces. It's a little bit different. So the probability is not changing as you keep asking people if they watch Game of Thrones. So we're just going to leave it like that. We're not going to, So is the sampling distribution approximately normal? We have to check the normal condition. So literally you have to do both n times p and n times 1 minus p. So the number of successes and failures, and make sure they're at least 10. Because otherwise it's going to be likely to be skewed right or left. So we take 1,000 and multiply by 0.75, and we should get 750 successes if we do take a sample of 1,000. Since we know the population is 75%, we should get about 750 successes and about 250 failures. So 1,000 times 0.25 is 250, and they're both greater than equal to 10. So we've checked the normal condition, and therefore we could find the probability of something occurring, which we'll do in the next example. But if the sample size were bigger, 9,000 instead of 1,000, can you tell me how that would change the sampling distribution? Do you think the shape would change? No, it would still be approximately normal. The shape wouldn't change, but and the center wouldn't change either, but the standard deviation sure would. And how much smaller would it be? Yeah, I think I heard 1/3. But standard deviation is 1/3 of the original, because you're taking the square root. If you look at the standard deviation formula, n is on the bottom. So it's like instead of n, you're doing 9n, and the square root of a ninth is 1/3. So it's going to be 3 times smaller, or 1/3 of the original, the standard deviation.